Hello again, it's Mr. Wakefield looking at the beginning of chapter 10 and section 10.1. I'm going to be looking at this entire chapter for the most part is going to be what they call conic sections. Examples of that are circles and then some other different shapes as well, including we're going to revisit parabolas, but it's going to be a different kind of parabola from what it was in 8.3. And so for most of the section anyway, we're going to be focusing on these different shapes, okay, which is they all together, they're called conic sections, but circles is one example of that. Before we talk about circles in this section, though, we're going to focus on these two concepts first, though, distance formula and midpoint formula. For example, if you go down to the first problem, you can see it gives us these 2 points on a graph right here. And I actually put them on this. You don't have to draw this over here. I'm just giving you a visual of what's going on here. But I put these 2 points on the graph, and it says find the distance between those 2 points. So in other words, what's the distance between these 2 things? Okay. And then also it says find the midpoint, which, as you know, what is a midpoint? It is literally the middle of, like, if you make a straight line between these 2 points right here, the middle of that line would be the midpoint, and it's approximately right here. And so you could probably guess, and we should never guess in math and rely on that, but you can guess just for the heck of it to realize that it looks like this is -1, -2 is the midpoint. But you should never guess because we want to be exact here. It looks like it's -1, -2 is the midpoint there, but we want to be completely exact, so it could be slightly off of that, okay? It could be very close to that point that I just said, -1, -2, but we need to be sure about that. I'll show you how to be sure about that, because the math is about figuring things out and being sure about it, not just guessing. So let's take a look at how to find the distance first. The way you find the distance is by using this formula up here. Okay, let me go ahead and put that next to the problem here. We have it side by side, or right down below it, I should say. But we'll have it close by so we can look at the formula and do the problem at the same time here. There we go, right there. And so this formula here, you can see it has a couple of minus signs in there. X2 minus x1, y2 minus y1. If that sounds familiar to you, it should, because we did something similar to that back in when we talked about graphing lines, okay? And in particular, finding the equation of a line. We did it for finding the slope, okay? See how we got y2 minus 1, x2 minus x1. Here it was part of a fraction. Here it's 2 separate things right here. But the way in which you plug in the numbers is very similar, okay? How did we do that back in chapter 2? All right, when we did this formula, how did we do it? We need to realize, and look at, here's an example of that formula right here, the fraction formula, where we did the second, on the bottom here, we did the second x minus the first x, x2 minus x1. But if you plug in a negative number behind that minus sign, that becomes a double negative. All right, and that's why it became plus right there. That same thing's going to happen here today in the distance formula. All right, if you plug in a negative number behind the minus sign that is already in the formula here, the minus sign right there, then in other words, it would be 3 minus -3. That's why when I wrote it in this problem right here, I wrote it 3 plus 3, because 3 minus -3 is 3 plus 3. Okay, so we're going to keep that in mind here as we do this current formula. All right, so what does this say here? Just similar to the slope formula, you take the second x minus the first x. Let's do that. 2 minus -4, the second x and the first x. 2 minus -4. There's that double negative right there. Okay, so 2 minus -4. I'm going to plug it into here, 2 minus -4, but because it's minus negative, that's going to be 2 plus 4. Okay? Only because it's a double negative. All right. if it had been 2 minus 4, if this had been positive, then you would actually keep the minus. It's when it's minus negative that it changes to plus. Okay, same thing here, all right? Put down the plus, just like the formula tells me to do. You got your bracket squared with the 2 x's on the inside. Here it says you've got a bracket squared after you put the plus, a bracket squared with the 2 y's inside of it. y2 minus y1, negative 3 minus negative 1. There's that double negative again where you have minus and then the negative right after it. And so that's going to be negative 3 plus 1. Again, if that had just been a 1 right there and you would have said negative 3 minus 1, that's different. Then the minus would have stayed there because it would have been minus a positive and it would have just stayed as minus. But minus a negative, that double negative makes it change into plus on both of these. All right. So it is normally minus, but when you plug in a negative number behind the minus, again, that's why it changes to plus. Okay, so this is the distance. How do we figure this out? Well, we do order of operations is what we do. Okay, that means when you do order of operations, you have to do the inside of a radical before you can actually calculate the square root itself. Okay. So the inside of the radical, what do we have? We have to do order of operations inside there as well. That means we do parentheses before exponents and exponents before the addition. Okay, so the parentheses are 6 and negative 2. Okay, and then we then do the exponents. We get 36 plus 4. Then the addition, we get 40. Now, now you do the radical, okay? And if it's a perfect square number underneath there, like 36 or 25 or something like that, then you actually evaluate the radical. But if it's not a perfect square number, all right, which 40 isn't, okay, then they just want you to simplify the radical. Okay, how do we simplify? We've done that many times before from back in chapter 7. You factor out the largest perfect square number. Okay, again, this is from section 7.3 if you want to review that, 7.3. You factor out the largest perfect square number. And then you evaluate the radical that had the perfect square number in it. So square root of 4 becomes 2. The second radical stays the same. And so your final answer is going to be 2 rad 10. Now you might be wondering, okay, so the distance is 2 rad 10. What does that mean? Okay, doesn't distance usually have like feet or yards or inches attached to it? You're right. But because there's no measurement in this problem, there's no mention, for example, of feet or yards or inches, okay, then you don't need to put it in the answer. So, but just from a real life perspective, what if you really had to figure out this distance? What would it be? Would it be feet, yards, inches, miles? What would it be? Okay, it's got to be something under normal real life circumstances. Well, it all depends on what these marks are. If this mark was 1 foot, 2 foot, negative 1 feet, negative 2 feet, not that we normally have negative feet, but if these things were 1 foot apart, then this would be 2 radical 10 feet. Okay, if this was if each one of these marks was 1 yard apart, then it would be 2 radical 10 yards. So I'm just letting you know, you don't need to write feet or yards here because they don't give us that. But in a real life situation, that's how it would work. Okay, so I just want to let you know that. Midpoint. It also tells us to find the midpoint. How do we do that? Well, midpoint, for example, let me just give you a nice simple little example here. If I said that you got 3 points on a quiz, okay, and then on the next quiz you got 5 points, all right, what would be the average of your two scores? Wouldn't it be 4? Okay, if I added up 3 plus 5, it'd be equal to 8, and then you divide by 2, it would be equal to 4, wouldn't it? Okay, well, it's not a coincidence that 4 is exactly halfway between 3 and 5, isn't it? Okay, the same distance. It's the same distance away from 3 as it is from 5. Talking about 4 here in the middle. So my point is that when you do midpoint, you guys, it is very closely related to average. Okay, taking the average of something. You don't have to write this down here. I'm just helping you understand that midpoint is very closely related to average. And so for that reason, since I want to find the midpoint, and since a point, any point really, is both x and y, it would make logical sense then that I would what? That I would, and it mentions it up here, that I would take the two x's and I would add, not subtract this time, but add, okay, before I divide by 2, just like I did with 3 plus 5 divided by 2. 3 plus 5 divided by 2, and that's where I got the 4 from there. And 4, again, is the midpoint between 3 and 5, because midpoint, by definition, is something that's halfway between the two things that you're looking at, in this case, 3 and 5. Okay, so that's why we add the two numbers and then divide by 2. So you add the two x's and divide by 2 to get the x part of the midpoint. And then see how you got the comma here to separate the x part and the y part? Okay, this comma here is like a normal comma that you would have in a point on a graph. Okay, so this is the x part, and this fraction is the y part of the actual point on the graph. All right, so you take the average of the y's right here, you add up the two y's and divide by 2, and that figures out the y part of the midpoint. So let's go ahead and try it, and then I'll talk about it some more here if you're still trying to get used to it. Okay, and I have the formula down here as well. So averaging the x's, we get negative 4 plus 2 divided by 2. Figure out what the numerator is equal to first, so that you know what the top and bottom are equal to, and then put this in lowest terms. And if I do that, I just get negative 1 over 1, which is negative 1. What about the y part? The y part, we take negative 1 plus negative 3. And when you add a negative, as you know, that's the same thing as just subtracting the 3 there. Plus negative 3 is the same thing as subtracting 3. But negative 1 plus negative 3 is negative 4 over 2. Now that I know what the top and bottom are equal to, I put it in lowest terms, and that's going to be negative 2. What does all this mean? Don't just leave your answer separate like this. It asked for what? It asked for the midpoint. So the midpoint means to put the x and y together. And as we suspected earlier when I put that red dot over here, okay, negative 1, negative 2 is truly the midpoint. Okay, so midpoint means you add, distance means you subtract. I know it ended up being addition here, but that's only because it was a double negative. The formula says to subtract for distance, you add for midpoint. Okay, be careful not to get that mixed up. Okay, let's do that one more time. This time it's got some radicals in our problem, but we'll be able to figure that out. Okay, we'll review how to deal with radicals here. First of all, the distance. The distance is going to be, again, you start out by taking the second x minus the first x. Let's write that down here since we haven't seen these radical problems here in a little bit. Okay, we saw them in chapter 7, and we see them from time to time more recently as well, but just from time to time. Back in chapter 7, we reviewed that 7.4 in particular, we had when you add or subtract, okay, whether it's addition or subtraction, if you know, if first of all the radicals have to be the same, okay, and then if they are the same, then the things that are in front of it, that's the thing that you add or subtract. Okay, but the radicals have to be the same. But the good news here is that they are, okay. You've got radical 3. So you take the numbers in front of each radical. Again, this is just when you add or subtract, and this is subtraction here, so that's why I'm talking about it. So we got, there's an invisible negative 1 in front of this here. You don't have to write it down, but I'm just highlighting it here. So we got negative 1 minus 2. Negative 1 minus 2 is negative 3, and then when you add or subtract radical terms, not only do the radicals have to be the same, but they need to stay the same. So the radical 3 stays the same right there. Again, this is all from section 7.4. Okay, and I actually got a little bit ahead of myself here. All right, which is fine. We can do that. I didn't write these things down separately. I wrote it down up here. Okay, but I went ahead and just subtracted it right away. Okay, because that's what we do first, like I did over here. I went ahead and combined the insides of the parentheses first. So I went ahead and just did that right away here. Okay, because I knew I was going to have to do that first. Just like the 2 plus the 4, I need to combine these right away as well. Okay, just like the negative 3 plus 1, I'm going to have to combine these two right away as well here. What is that? That's 3 let me write that down up here. 3 radical 6 minus radical 6. This is what? This is the second y value minus the first y value. Okay, I'm just writing it down up here. This one was the second x term minus the first x term. Okay, and so what is this equal to? Well, we know that the radicals are the same, and we know that they're asking us to subtract. And so that means that since the radicals are the same, they are going to stay the same. But then we do 3 minus the invisible 1 right here, which is 2. Okay. Remember, if there's nothing in front of the radical, that means that there's an invisible 1 there. Okay. And so that ends up being 2 radical 6, doesn't it? Okay. Next. How do we square a radical term? Okay, we talked about this briefly back in chapter 7 as well. It's a couple different ways to do it. What I like to do is I like to just simply multiply it out like this. There it is. I like to multiply it out like this. And the reason why I like to do that is because we learn that when you multiply a radical term times another radical term, you multiply the outside times outside, the outside part times the outside part. And then you multiply the inside part times the inside part. The outside times the outside stays outside in the answer. The inside times the inside stays inside in the answer. So the inside 3 and the inside 3 become the 9 on the inside. Okay. And then we simplify the radical, which is 3. And so this whole thing ends up being equal to 27. Okay. So this whole thing right here, when you square that radical term, is 27. What is this one when you square it? That one is 2 rad 6. Since we're squaring it, we multiply it twice. That's why I'm doing this. Okay. When you multiply a radical term, remember a radical term officially is when you have a radical with a regular term being multiplied by it on the outside. Okay. Sometimes that thing will be invisible. Okay. Like for example here, the negative 1. If you have a negative, it's just negative 1. All right. Is the outside part. But here it's visible. You have a 2 on the outside of both. So, but a radical times a regular term on the outside, that's a radical term. So multiplying radical terms together, you do outside times outside stays outside. Inside times inside, 6 times 6 stays inside. And then you simplify that radical after that. We get 4 times 6 is 24. 24. Okay, so this ends up being what? This ends up being 27 plus 24 right here, which is 51. Okay. Just like we did in the last problem, after you figure out what the inside of the radical is equal to, look and see if it's a perfect square number on the inside. If it is, evaluate it. Like, for example, if it had said square root of 49, you would say 7. Okay, you don't just leave it as square root of 49. But since this is not a perfect square number, just try to simplify it like I did in the last problem with 40. Okay, however, 51 does not simplify. You can't factor any perfect square numbers out of that. like a 4 or a 9 or a 16 or anything like that. And so I'll just leave the answer like that because it is already simplified. It cannot be simplified anymore. Whereas this one, I was able to simplify it, so I simplified it before I came up with before I circled the answer. Okay, I want to simplify it first there. But this one doesn't simplify, and so we'll leave that alone. What about the midpoint? Remember, midpoint means what? It means that we don't subtract, we add. And so we're going to take the two x's here, we're going to add them together, and then divide by 2. Okay. So we got 2 radical 3 plus negative 1 radical 3. Remember, plus a negative is the same thing as subtracting. So you have 2 radical 3 minus radical 3. Again, there's that invisible 1 in front of that. So we're actually doing 2 minus 1 on the outside, aren't we? 2 minus 1 is equal to 1. You could put a 1 there if you want. But remember, when it's 1 on the outside, you don't need to write it. You don't need to write the 1. If it's negative 1, you got to write the negative. But since it's positive 1, you don't have to write anything on the outside there. Okay. If there was something being added to it in the front of it, that would be different. Then you'd have to put a plus or something like that. Okay. But since it's the only term there, you don't need to write anything because it's just a 1 on the front there. So we did it. We figured out the x's there using this formula. Let's do the same thing with the y's now. Okay. So I got radical 6. It's the y. You might be wondering, why am I doing the y1 and the y2 in that order? Well, actually, you know what? My bad. It does say to do that anyway. But what I'm trying to point out is that since we're adding, it doesn't matter what order you do it in. Okay, when you're adding. When you're subtracting, theoretically, it does matter, yes. Okay, what order you do it when you subtract. Otherwise, you'll get something different, at least on the inside of the bracket you would. But yeah, we need to add the first y and the second y. Again, since you're adding, you could do it in either order there. You could do the second plus the first. It's going to come out the same. So what do we get here? So again, since these are radical terms with the same radical, and since we're adding them, okay, the radical is going to stay the same when we're done adding, and then we have 1 plus 3, don't we? On the outside, we have 1 plus 3, and so that makes it 4 on the outside. Okay. I could not reduce that down to lower terms. You can do this one. We talked about back in Chapter 7 that if you have a radical term and a regular term without a radical underneath it, you're allowed to put it in lowest terms as long as it's a single term on the top and bottom, single radical term, single regular term. Okay, the only requirement is that you cannot cancel inside the radical. But you can cancel the 4 and the 2, and I end up getting 2 radical 6 over 1. Same thing as 2 radical 6. Nothing cancels here, and so I just left that alone. Okay. So the final answer for the midpoint is going to be rad 3 over 2 is the x part, and 2 rad 6 is going to be the y part with the comma in between, like we always put when we're doing a point on a graph, and that's what a midpoint is. And there you go. Okay, so what I'd like you to do right now is please try 1 and 2, problems 1 and 2. They're very similar. Okay, and then after you're done doing that, we'll take a look at the answers and just hit the play button. Okay, let's take a look at number 1. Second x minus first x, 4 minus 0. Okay. Again, since the 0 is not negative, all right, you don't have the double negative like we did previously. And so it stays as minus. We have 4 minus 0. Here, though, we have 3 minus negative 2, the second y minus the first y. 3 minus negative 2, since there's a negative number plugged in behind the minus sign that would normally be right here according to our formula that we had, x2 minus x1. In fact, I write it down up here. You don't have to write it down like this, but that's officially how it works out. It's x2 minus x1, which is negative 2. All right, so 3 minus negative 2 becomes 3 plus 2. You can write it just like that. You don't have to put the double negative in there. You can just change it to plus. And so that's how it comes out. We then do our order of operations here. That means the parentheses, we get 4 and 5. After that, we then do the exponents, and that gives me 16 and 25. We then finally add, and we get 41. And the reason why I circled that answer is because I can't simplify that radical. If I could, then I would have. All right, and I would have taken it one step further in the problem, like I did in problem A up here when it changed to 2 rad 10. Okay. How about the midpoint right here? The midpoint is going to be done by adding the x's and y's instead of subtracting them. Okay. So for the x's, we get 0 plus 4 divided by 2. You get 4 over 2, which reduces down to 2 over 1. And then for the y's, we get the first y plus the second y. We add them together. We get 1. Divided by 2 is 1/2. That's already in lowest terms, so 1/2 is the second part of the answer. So the final answer is 2, 1/2. Putting the x and y together as a ordered pair, because a midpoint is an ordered pair. Okay? So remember, distance is just one number, you guys. But because midpoint is a point on a graph, it's an ordered pair. It's got to have the two parts. Okay, with the parentheses around it, like we always write an ordered pair. Okay, don't forget those parentheses. And in number 2, okay, the distance formula. We do, again, the second y minus the first y, so I wrote that down here. The first y was positive, and so it's not a double negative. That's why the minus is still there. Same thing over here. We got the second, or I'm sorry, I meant the second x minus the first x, not y's. Okay, the second x minus the first x. The other part, though, is the second y minus the first y. And so, again, the second y it's positive, and so the minus stays minus. It's not a double negative. And so you still see the minus there. We then do order of operations. That means what? That means to do negative 2 minus 2. The radical stays the same, so we get negative 4 radical 3. Here we got 5 minus 1 because the radicals are the same. 5 minus 1 gives you the 4, and then the radical stays the same. Okay. Then we square these things. If you square them, let me zoom in here. I know I kind of wrote that small. Okay. If you square these things, you would get negative 4 times negative 4, just like I did problem B. Okay, you get negative 4 rad 3 times negative 4 rad 3. If you multiply the outside parts, you get the 16. If you multiply the inside parts, you get the 9. Inside times inside stays inside, though. So you get 16 rad 9. But 16 rad 9, let me just write it down here. It's easier to see. 16 rad 9 is, you then simplify the radical, you get 16 times 3. And that is where the 48 comes from. 16 times 3 is 48. So same thing here on the 4 rad 6. If I square that, that means to multiply it twice. We get outside times outside. 4 times 4 is 16. Inside times inside. 6 times 6 stays on the inside. So you get 16 radical 36, which then becomes, after you simplify the radical, 16 times 6. I can write it down here as well. All right, and then 16 times 6 is 96. That's where the 96 comes from. Okay, so a little bit tougher to work with radicals, isn't it? All right, but we got through it there. Now we add and we get 144. But hey, that's a perfect square number, so we can actually evaluate this radical when it's a perfect square number, and we should. It just ends up being equal to 12. So don't leave the radical the way it is there when you have either a number that can be simplified like 40 was in problem A, or if you've got a perfect square number, actually evaluate the radical and you can make the radical go away. It's just equal to 12. Okay, so the radical can go away. A square root radical can go away, as we learned in chapter 7. All right, if it's got a perfect square number underneath it. Okay, like 25 or 36 or 49, or in this case, 144. Okay. What's the midpoint? Midpoint, you add the x's. Okay. 2 plus negative 2 is 0. 0 radical 3 is the same thing as 0 because you're doing 0 times radical 3, and 0 times anything is 0. Okay. So that's why I wrote 0 there. 0 divided by 2 is 0. What about the y part? The y part is, again, I'm adding together the y's. Rad 6 plus 5 rad 6. I just highlighted the invisible 1 that was in front of the 6 here. Again, you don't have to write the 1 there. But we do know that there's a 1 there, so it's 1 plus 5 equal to 6 rad 6. The 6 and the 2 reduce down to, just like I said there in problem B, you can reduce the 6 and the 2. You just can't cancel inside the radical there. We get 3 rad 6 over 1. So putting those two answers together, we get 0, 3 rad 6. That's your final answer, okay, for the midpoint. Okay, so that's distance and midpoint. Okay, now what we need to talk about is, as I go back to a nice clean sheet of paper here, is circles. And so going down here to the first set of circle problems, all right, before I even get into that though, what is a circle besides the fact that it's round? Because not every round object in the world is a circle, okay? So what makes a circle as opposed to some other round object? Well, every circle has a center point. I'll just put that right there. I'll just say that that's the center of the circle. And then if I draw a circle around it, what makes it unique versus other round objects? Okay, what makes it unique is that every single point on a circle is the same distance away from the center. Every single point. This point, this point. I'm just coming up with some random points here, okay? You don't have to actually highlight all these things. But all of these points that I highlighted right here, they're all the same distance away from this center point here in the middle. Okay, that's what makes a circle a circle. Whereas if you had some round object like this, okay, with a center in the middle, that's not true that all the points are the same distance away, is it? This point, for example, is closer to the center than, say, this one way the heck over here. Okay, so this is not a circle, but because all of the points on this shape are the same distance away from the center, okay, that is going to be a circle. All right, this is what we call an oval shape, but it's going to have a special name here that we'll talk about in the next section. All right, we'll get to that. Right now we're focusing just on circles. Now what I want you to notice as we move further here in the circle discussion is that look at this equation here. It says that this is the equation of a circle. There's a close relationship between this and this, okay? You'll notice that if I change the D to an R, okay, if I change the D to an R like I have an R down here, and then I square both sides of this formula here, which would then get rid of the radical, it'll look very similar to this. I'll have different letters inside my brackets, but otherwise it'll look very similar. All right, I won't get into the deep theory behind what the relationship between distance and circle, or I don't want to bore you with that. But I just want you to realize there's a close relationship there. If you square both sides of this formula, it looks very similar to this. And by realizing that D and R are very similar here, because if I do square both sides, this would then be D squared. And like I said, if D and R are thought of the same way, that would then make it R squared. And that's where this R squared came from. So what I'm getting at here is that since the distance is the same all the way around, okay, and we have a name for that distance. That name is called the radius. And I'll call it R for short. I'll call it R for short right here, okay? But that's the distance from the center to any point on the circle because all the distances are the same. Okay, so this is also a distance of R. All these other ones are also a distance of R. What is R? Well, it's called the radius, but it's going to be different depending on the problem. Okay, so like if r was equal to 3, then that means that this distance would be 3, this distance would be 3, they'd all be 3. Okay, so the r is going to be a constant number. Remember, it's constant. That means it stays the same. The distance is supposed to stay the same for all of the points on the graph. And so that's, again, without getting into too much theory here, all right, that's a relationship between the distance formula and the circle formula. The distance is supposed to stay the same, and it's going to be the radius. But then it becomes r squared when you square both sides and get rid of the radical. Okay, so a basic explanation of the relationship between those two things. Don't worry, I'm not going to make you write an essay on the relationship between those two things. I just wanted you to get some perspective there on distance and circles. Let's go ahead and try using this formula now. This is similar to when we did parabola problems, where in the parabola problems, we had a couple of variables here. Okay, let me look at this as an example here. Down here, the x and the y were what? The x and the y were the variables, and the a, the h, and the k were the constants. Okay, there's an invisible a right there, 1. There's your h, and there's your k. Okay, so the a, the h, and the k were the constants. The x, and then this is the y right here. Those are the variables. Why am I pointing this out right now? I'm pointing this out because in this formula here, let's look at it side by side. I'll zoom out for you. Looking at it side by side, the x and the y are the variables, and the h, k, and r are the constants. H, K, and R. Okay. H, K, and R. So when you see a problem where you've got X and Y right here, you got the two brackets. The brackets are being squared. Okay, you got the X and Y right here. You've got constants here and here. These could also be pluses. All right, I'll talk about that as well. But and we saw that with parabola problems as well. You could have had a plus inside the bracket there as well, and it didn't keep it from still being a parabola. Same idea here. These are constants, though, and then this is a constant as well. All right, so let me look at an example on the back side of the worksheet here. You'll see a visual of that. Here we go. So you got your X and Y. You've got your what? You've got your you got a constant right here, +1, -4, and then 25. Okay, so if you've got an X and Y right here with constants here and here, and then a constant over here with no variable over here, and then you've got the bracket squares with the plus in between it, all that stuff. All right, in fact, I've got it written down right here. I just rewrote the formula from the front side of the worksheet here. With the X and the Y and the constants in green here. All right, those are what? Those are, when it looks like that, when it looks like this formula up here, that means it's going to be a circle. And they give it away anyway. They tell you that it's going to be a circle, but I'm just telling you for future reference. When it looks like this, with the X and Y, and then the constant numbers in the appropriate place, with the brackets being squared and the plus in between it, that is going to be a circle. All right, well, I'll get to how to do those problems here coming up, but wanted you to see that. And so that is what the circle formula looks like, at least one of the formulas. Referring to that now, let's see how to do these first few problems before we go to the back side of the worksheet. Okay, so I've got the equation of a circle here. Okay, they are telling you that it's a circle already. So they're saying come up with the equation. Well, all you need to do is realize that the h and the k, according to my directions here at the top of the page, the h and k together, just like it was with the radius, I'm sorry, not the radius, the vertex of the parabola. Remember we had h comma k for that as well, but now it's the center of the circle. So you take the h and the k, but notice here's the difference between this and the parabola. In the parabola problems, remember we said that when it's inside the bracket, it's going to change signs from -1 to 1. But when it's out here, it doesn't change sign. The reason why it does that is because when it's inside the bracket, it's minus. But when it's outside, it's plus. So if it's minus, you change the sign. -1 changes to 1. But then when it's outside, because it was plus k, plus, we don't change the sign. The 3 stays as 3. It doesn't change to -3. Well, this time, you guys, both the h and the k have minus in front of them. Both of them. So that means we change the sign of both of these numbers when we plug it in to the equation. All right? Kind of like when we did the distance formula. If you plug these in, you get minus negative. That's going to become plus. Okay? I'm just plugging it straight into this formula here. I'm starting to write it out. Okay? And then since 5 is just positive 5, you're just doing y minus 5. There's no double negative there. It's not minus -5. It's just 5 that you plugged in. Okay, so it's y minus 5. So if you plug in a positive number behind the minus, just like we did in the distance formula, the minus stays there. But you see what happened here? The -3 changed to +3. The 5 changed to -5. All right, that's what happens there when you got the minus inside the bracket, just like with the parabola. Same idea. And then on the other side it says r squared. So please remember, you guys, you do not put 3 over here. R is 3, so r squared is what? R squared is 9. Okay, so you got to remember the right-hand side of the equation when you do a circle equation, it is not just r, it's r being squared. Let's try that again right now. Okay. In fact, you know what? I'm going to let you guys try it now since these are numbered problems. Just do the same thing I did here. Change the signs of the numbers that you're plugging in to the brackets, and then remember to square the r. Hit the play button when you're done doing that. Okay, so number 3, how does that come out? Because this is +2 and -1, when it goes into the formula, it's going to be x minus 2 and y plus 1. 2 becomes -2. -1 becomes +1. Okay, just like if you're plugging something into the distance formula. All right, remember it's got to be a minus or a plus. All right, one of those two things. Don't forget to put the plus there if it's positive. Okay. So, and then on the other side, we don't just put 4, do we? We got to say r squared. So since r is 4, r squared is 16. Okay, let's try that one more time here. Number 4. In number 4, because it's -5 and -3, it's going to become +5 and +3 when you put it into the equation formula for the circle. All right. So as you go from the center, if they give you the center and they ask you to come up with the equation, it changes signs as you go from the center that they gave you into the equation. All right. And then if r is square root of 5, then that means we need to square this thing in order to figure out r squared. And as you guys know, when you square a square root, as long as it's a normal square root and it doesn't have like a negative on the inside of it, okay, and I know we've seen negatives on the inside of square roots when we talk about complex numbers, imaginary numbers, in other words, but there's no i's here when you talk about xy graphs that are on an x-axis and a y-axis. Okay, so but that we don't need to worry about that here because there's not a negative inside of there anyway. And if there's not, then when you square a square root, if there's no negative on the inside, then that is going to be it's just going to be equal to the inside of the radical. The square root and the square cancel each other out when you have a positive number on the inside. So it just becomes 5, doesn't it? Just like when we would square both sides of an equation, when we had a radical equation, the radical cancels out. It's the same thing. Okay, so it just becomes 5. So that is how to find the equation of a circle when you are given the center and the radius in the problem. Okay? So let's go ahead and flip that thing over to the back side, and we have a few more problems there. Okay, I'm now on the back side of the 10.1 worksheet. And you can see here that this equation looks just like this. All right, and we talked about that a few minutes ago when we looked at this first problem. Okay, if you have, again, x and y, all right, and then you got either addition or subtraction with a constant number next to the x and y. Both of those brackets are being squared with the plus and the constant number on the other side, which could be your r squared. Then it all fits into being a circle. And so, and they tell us it's a circle anyway, but I'm just saying, okay, because sometimes it's not, see how this problem right here, it doesn't look like this, but it still tells us it's a circle. That's a good clue for us. It tells us that I need to, because I know this is a circle right here, it tells me to convert this equation so that it looks like this eventually. I'll talk about how to do that when we get to that problem. But we don't need to do any converting here because it already looks like it's supposed to look. And as long as it does, then we can figure out, kind of like with the parabola problems, if it already looks like this right here, when we did the parabolas, you can, and you can see that right here, then we were able to figure out the vertex right away, okay? It's the same idea. When it looks like this, you can figure out the center and the radius right away, okay? Because the center comes from the h and k numbers, and then the radius comes from the number on the other side. Let's do that carefully here. Now remember, I said that when you go from the center to the equation, back when we did those problems on the front side here, when you go from the center to the equation, it changes signs. The h and the k change sign. Okay, it's the same thing going backwards now. If you go from the equation back to figuring out what the center is, again, it changes signs. So the +1 and the -4, that becomes -1, +4. The 1, of course, is the x part of the center because it's in the same bracket as x. The 4 is the y part of the center because it's in the y part of it's in the y bracket. Okay, so that's how I knew to come up with that answer right there. What is the radius? Well, remember, the number that's on the other side is r squared. So that means that r squared is 25. Now, normally when you solve this equation in order to figure out what r is, you would get a double square root. When you have a variable squared equal to a constant, you would say plus or minus square root of 25. Okay? But, and I'll write that down, in fact. This is r is equal to plus or minus the square root of 25. However, there is no such thing as a negative radius because radius is a distance. So officially, it is only square root of 25, and that's why the r is going to be equal to 5 here. Not -5 because there is no such thing as negative distance. So it's still true that this is plus or minus under normal circumstances, but because radius can't be negative, we just go with the 5 as our answer there. Okay, so we found the center and the radius as the problem asks us to do up here. Then it says graph the circle. Okay, here's how you graph a circle. You take your center first, okay, which is right here. Go ahead and plot that. Okay, then you go ahead and take your radius, and we're going to do, remember, radius, if the radius is 5, that means that all the points on the circle are a distance of 5 away from the center, all of them. Now, that doesn't mean you need to plot a whole bunch of them. The easiest way to do a circle, you guys, is to just go 5 to the right. Count out 1, 2, 3, 4, 5. Go 5 to the left. 1, 2, 3, 4, 5. There it is right there. I'm also going to go 5 up. 1, 2, 3, and I'll make a couple more marks here in order to fit that in. So 1, 2, 3, 4, 5. There we go right there. And then finally 1, 2, 3, 4, 5 down here. And then you draw the circle. How do you draw the circle? The biggest mistake students make, you guys, when they do the circle, all right, I see it a lot. Please don't let this happen to you, is that they make their circle look like a diamond. Like if you ever watch baseball or play baseball or softball or something, what does a diamond look like? A diamond looks like that, okay? No, that is not what it looks like. That doesn't look like a circle, does it? No, 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 okay? Sometimes I'll go, oh, you know what, I'll make it look like a diamond, but then I'll make it curved on the edge. That's still not good enough, you guys. This is not good enough either, all right? That still looks like a diamond. A diamond with curved edges. That's still not a circle. How do you draw a circle so that it actually looks like a circle? Let me show you that right now, but don't do this up here, okay? Here's how you do it. What you do is you take any one of the 4 points and you start at that. I don't care which one of the 4 you start at. I'll start out at the bottom one here. What you do is instead of going straight to the next point like people do when they make a diamond, is you go away from the center a little bit like this. I'm going away from the center, all right? Instead of going straight to the next point, away from the center a little bit, and then slowly cut back towards the next point like that. And you keep on doing that for all 4 points here. So watch what I'm going to do here. I'm not going to go straight to the next point here. I'm going to cut away from the center, a little bit further away, and then slowly cut back towards the next point. All right, and we keep on doing that. Away from the center, and then slowly cut back towards the next point. Away from the center, and then slowly come back towards the next point. See how it now looks a lot more like a circle than this does? So that's what I need you to do, okay? It doesn't need to be the world's most perfect looking circle. This is not a perfect circle either, okay? But by doing what I just showed you there, it'll make it a lot easier to make it look more like a circle, all right? But I can't have a diamond. That would not get full credit, okay? No diamonds, all right? Okay, as we move on to problem E here, obviously it tells us it's a circle, so we know that it needs to look like this eventually because it's a circle and circles are supposed to look like this. So if it doesn't look like this with the 2 brackets being squared, if it looks like this instead, what you need to do is the following steps here in order to make it eventually look like this. What I need you to do is, first of all, take the constant term. If it's on the left-hand side, see how this is the term that doesn't have a variable in it? There's 5 terms over here with the pluses and minuses in between it. 5 terms. This is the only one that doesn't have a variable in it. So if you've got a 0 over here and then you've got a constant term on the left, what I need you to do is add or subtract it over. In this case, I'm going to add it over. Okay. You know what? To save some space here, I'm not going to actually write that down. I'm going to just do it here. But that's what you do, though. You add that over. If it had been plus 4, you would subtract it over. But before you finish writing this out, though, I need you, and I'll put the 4 over here because I added the 4 to the other side. But what I need you to do is I need you to put the x's together with the x squared first and then the x. And then I need you to put the y squareds together, but leave some space in between the x term and the y squared term. Leave some space. There's a very good reason for that. We'll get into that. And then what you do is you put the y squared and the minus 6y together with the y squared first again. Okay, so x squared, x, space. Y squared, y, space. In fact, I don't need that much space. I can put the 4 a little bit closer there. But we're going to fill in those 2 empty spaces with particular numbers here. What numbers are they? Well, doesn't this look kind of like completing the square? Remember how we had x squared and then x, and then we added something to that? Well, what we have here this time is we have x squared and x, and then an empty space. We're going to add something to that. But we also have y squared and y in an empty space. So what that means, you guys, is we are going to complete the square twice. We're going to complete the square with the plus 12, and we're going to complete the square with the minus 6 in exactly the same way we did back in 8.2. All right, you take the coefficient of the x to the first term, you divide by 2 and you square it, and then that's what you add. So we're going to do that right here. We're going to take the coefficient of the x to the first term and also the coefficient of the y to the first term. Okay, let's do that up here at the top. So I go divide by 2 and square. Divide by 2 and square. We do that with both of those coefficients for the x term, x to the first term, and the y to the first term. Okay, what do we get? We get 6 squared, which is 36. And then on the other one we get, again, you do parentheses before exponents. So negative 6 over 2 is negative 3. We square that, we get 9. So what we do then is we take the 36 and the 9, and we add that to both sides. Or add the, well, I'll get to both sides in a minute here, but we add the 36 to this part because the 36 came from the x part here, the 12. So you make sure to put these in the correct place. Since the 36 came from the 12, which is the x part, put it with the 12, put it with the x part. And then since the 9 came from the negative 6, which is in the y part, we need to put the plus 9 with the y part. Okay, but don't forget, just like we did back in 8.2, don't forget that if you add something to one side, you have to what? You have to add it to the other side. Okay, I apologize, by the way. This is not from 8.2. It's from 8.1. The completing the square technique is from 8.1. I didn't mean to throw you off there. Okay, so if you need to review that at all, it's in 8.1. So we got to add these two red numbers to both sides here. Okay. All right, now, what did we do when we completed the score after we did that? We then factored this so that it has to be two brackets, and it will be if you do it right. It has to be two brackets, and if you do it right, they'll be the same bracket. Okay, but I showed you a shortcut as well. I told you that the number that you square, not the number you ended up with, which was in this case was 4, and in the current problem it's 36 and 9. No, not those numbers, but the number that you square, that's what goes inside the bracket. Okay, negative 2 is what we squared, minus 2 is what goes in there. So, as a shortcut, this thing right here, you guys, becomes x. And then since it was positive 6 that I squared, it's x plus 6 squared. And if it's positive, don't forget to put the plus there. You got to have the plus there. But that's what happens, though. All right. If it is positive, it's plus. If it's negative, then, of course, you'll have the minus there. What does this become right here? And bring down that plus that's in front of the y squared. That comes on down. Okay. But then what is this bracket if you factor it? What's the shortcut to factoring? The shortcut is to realize that, just like on the x part here, what you squared, not the 9, but what you squared to get that number that you added to both sides here, that's the number you put inside the bracket. So that was negative 3. So y minus 3. Again, very similar stuff to what we did in section 8.1. What's on the other side here? 4 plus 36 is 40. 40 plus 9 is 49. And now, you guys, now it looks like this over here. It now looks like the circle formula that we've been talking about. Okay? This one right here. It looks just like that now. Okay, with your two variables in red and the constants in green, all that stuff. All right, it's okay to have the plus there. It just means that the h is going to change sign, all that stuff. All right. And so now that I know, now that I have it in the correct form here with the two brackets and everything, what's the center and radius? So the tough part is done here. Okay. Now it's just like the last problem. The center, remember when you go from the equation to figuring out what the center actually is, the two numbers that are the center, your ordered pair, you got to change the signs. So 6 becomes negative 6. Negative 3 becomes positive 3, just like I did here when I changed the signs to get negative 1 and positive 4. Same thing here. Okay, remember the number on the other side, and again, Do not do this until you get it into the correct form. Don't figure out the center and radius because these numbers are changing as we go along. Wait until you get it into the correct form, all right, for the center that I just showed you here. Wait until you get it into this form. Then ask yourself, what's the r squared? Then ask yourself, what's the h and the k, which I just did. Okay, so that means we use 49. We don't use 4, we use 49, and we say, okay, if r squared is 49, then what is r? Well, what's the square root of 49? It is 7, isn't it? And that's why the radius is 7. Okay? So when you go from the equation to figuring out the radius, you got to take the square root because this is a r squared. Okay? It's the opposite of what we did on the front. On the front, when you go from the radius to the equation, you got to square it. But when you go backwards, you do the opposite thing, which is to take the square root. Okay, if I started out with this equation and I said, we don't know what the radius is yet, but you need to figure it out, then you would take the square root of 9, wouldn't you? If this was the beginning of the problem right here, this equation, and I said, hey, what's the radius? You would take the square root of this, and it would give you 3 right there. Okay, so going from the equation to actually figuring out the radius, you go backwards and you do the square root instead of squaring it. Okay. Now, because we have a -6 and because the radius is pretty big here, I'm going to change the scale here a little bit. But I really need to make this clear, you guys. When you do circles, you have to keep the x and y scale the same. Otherwise, that whole thing about all the points being the same distance away from the center, which it has to be with a circle, that would not look right. Okay, we don't have to do this with the circles. We don't have to do this with lines and parabolas. But if you're going to change the scaling, like let's say for example, I did 2, 4, 6, 8, 10. Let's say I did it that way. Each mark is a distance of 2 away from the next mark. Let me zoom in there so you can see that better. Each distance is each mark, is a distance of 2 away from the next mark. We got 2, 4, 6, 8 instead of the normal 1, 2, 3, 4 right here. 2, 4, 6, 8. Okay, pardon me if that's not easy to see there. I apologize. Sometimes the pencil doesn't come out very well on the screen there. 2, 4, 6. That's a little bit better. 8. But that's what these are. 2, 4, 6, 8 each mark there. Okay, when you're going to do that scale, you guys, then your y-axis has to be the same scale. It has to be 2, 4, 6, 8 as well. Each mark has to be the same distance apart on the x-axis and the y-axis when you're doing circles. Okay, if you're doing lines and parabolas, the x-axis and y-axis can be different from each other. In other words, the x-axis could be 1, 2, 3, 4, and the y-axis could be 2, 4, 6, 8, for example. We saw that in a lot of the parabola problems, in fact, from section 8.3. But here, if you make the, for example, let's say you made the x-axis 1, 2, 3, 4, and you made the y-axis 2, 4, 6, 8, you're going to have a circle that doesn't look like a circle. It'll be completely distorted, okay? So that's why I'm saying the scaling for the x-axis and y-axis need to be the same. So you can change it. You don't have to do 1, 2, 3, 4, but it's just got to be the same. So that means that -6, 3 is going to be right here. Because remember, -2, -4, -6, and then right here, 3 is halfway between 2 and 4, and so that's why the center is right here. Now, when you count out the radius, you got to be careful here because it's 7 and each mark is 2. So you got to go 3.5 marks. I'll show you that. Don't worry. So, but remember what we did in the last problem. In the last problem, because the radius was 5, we're going to count out 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 down. And 1, 2, 3, 4, 5 up. Same thing here with the 7. We're going to go what? We're going to go 2, 4, 6, and then 7 is halfway between 6 and 8, so it would be right there. Okay, let's go 7 to the left now. 2, 4, 6, 7. Again, I'm going 2, 4, 6 because each mark is a distance of 2. I now need to go 7 down. So I'm going to go, notice I'm already halfway between the marks. And so to get down to this mark right underneath it here, this grid line right here, okay, I just go down 1. So 1, 3, 5, 7. And that takes me down to -4 right here. This is -2, and this is -4 on the y-axis. Doesn't that make sense that if you go from 3 down to -4, that's a distance of 7? Okay? Because -3, or pardon me, 3 down to 0 would be a distance of 3, and then 4 more would be a total of 7. If I then go up, I need to go up 1 to get to this next mark right here because the center, because again, we're only going half of a mark here just to get up to here from where the center is. So we go up 1, and then 3, 5, and 7. That takes me right here. There we go. And now you can see that a circle is starting to develop here. How do we draw the circle? Not a diamond, right? But what do? We go away from the center and then cut back to the next point, like this. Away from the center and cut back to the next point. Keep on doing that. Away from the center, cut back to the next point. Nice and round. Okay, remember, circles are always round, so no sharp edges, no sharp turns. Okay? Just like with parabolas, no sharp turns. And that looks like, reasonably speaking, that looks like a circle, doesn't it? But it's not a diamond, right? Okay. So that is how you do it when you have the equation looking like this. You got to make it look like this with the 2 brackets. And you do that by what? You do that by moving the constant term over if it's not over there already. Not talking about the 0, but the non-zero number over here that doesn't have a variable in it. Move that over. I did that with the 4. Group together the x squared and the x, the y squared and the y, but leave some space to add something to those. Complete the square twice, and then do that little shortcut factoring technique I taught you where the thing that was being squared goes inside the bracket. And then it will look like the equation that it's supposed to look like. And you go from there. So please try 5 and 6 right now and hit the play button when you're done. Let's see how you do. Okay, looking at number 5 right here. What is the center right here? It is already in the form that I need it to be in, right? Okay, with the 2 brackets and the plus and the constant number over here. Okay, it's the circle formula that we talked about. So the center, that means I get it, since it's in the correct form already, I can figure out the center and the radius now. I don't have to do all the stuff that I'm going to need to do over here. Okay, that's a whole different story, but here it's already done for me. I can do the center and radius right now. So what do I get? The center and the radius, again, you change the signs of the numbers that are with x and y to figure out the center. -1 becomes 1, +2 becomes -2, and then the radius, you take when you go from the equation to figuring out the radius, you got to take the square root because you got to convert r squared to r, and so that makes it 2. The square root of 4 is 2. Now that I know the center and radius, I go ahead and put my center on my graph, and then I count what? I count 2 to the right, because the radius is 2. I count 2 to the left. I count 2 down, and I count 2 up, all starting from the center and going out. Okay? And then I draw my circle. And there you go. That is problem number 5 right there. Okay? That's number 5. Okay, number 6. What I do is, again, as I move the 8 over to the other side, and you can see I did that here. I subtracted, because it was +8, I subtracted it over. Again, why do I move that term? Because it's the term that doesn't have the variable in it. I need the variable terms, just like I've done in the past with completing the square. I need the variable terms on the left, the terms that don't have the variable in it, such as -8, on the right. I then, where did I get the 16 and the 1 from? Remember, you got to add a number to the x's and add a number to the y's. Where did those two red numbers come from? They came from the fact that I take the +8 and the -2 and I complete the square on those. And you can see that I got 16 and 1 right here. So I add 16 and 1 to those two things right there. But if you add 16 and 1 to one side of the equation, as we learned in completing the square back in 8.1, you have to add 16 and 1 to the other side also. Okay. The only difference between this and 8.1, like I said before, is that you're doing the completing the square technique twice. Once for the x and once for the y. So that's why you're adding two numbers over here instead of just one. How do I figure out what the brackets are equal to here, though? Okay, just like you did in 8.1, you take the number that was being squared, not the 16 and the 1, but the number being squared. That would be +4 and -1, and that's exactly what goes in there. +4 for the x, -1 for the y. And now it looks just like the circle equation is supposed to look, doesn't it? So that means I can now figure out the center. What's the center here? Well, you got to figure out the opposites. You got to take the opposite sign of the numbers that are with the x and the y. So that makes this -4. You don't change the equation to -4. I'm just saying when you figure out the center, you change the signs coming down when you figure out the center. So this becomes -4 when you figure out the center. This becomes +1 when you figure out the center. And then what is the radius? When you go from the equation to figuring out the radius, you take the square root. Square root of 9 is 3. Not -3 because, again, there's no negative radius. So it's just 3. And then I go ahead and graph the center first. You got to start out with the center. Okay, you can't do the radius unless you have a center to measure from. And then speaking of measuring, we then go 3 to the right. And we go 1, 2, 3 to the left. We go 1, 2, 3 down. And we go 1, 2, 3 up. 3 in each direction. And you draw a circle. And you did it. Okay. You draw that circle. And that's what they wanted you to do. Okay. They wanted you to find the center and radius and then draw the circle. So that concludes section 10.1. Okay. We'll see more shapes here in the next few sections. But right now, let me know if you have any questions about distance formula, midpoint formula, or circles. Okay, let me know, and you have a good day. Take care.